have started it to record, and you can also record locally.
Okay, yeah, I'll just do that now. Okay, it should have sent a request to you.
Yeah,
Okay, sweet. Am I good to start?
so yeah.
Okay,
Go
brilliant. Yeah, firstly, thanks everyone for joining. I'm Jack, I work in the Kubernetes team, and I'm just going to give a brief overview of some specific runtime security things that you can do in Kubernetes, and then also explain one of the recent integrations that we've done in the CERN Kubernetes clusters as part of the last release that we did maybe a month ago now. Obviously, this topic is like super expansive, so what I'm going to go through is by no means completely comprehensive. I'm just focusing on a few small things that are probably the easiest things to get started with initially, and then I guess once you tick these off, you then move on to more complicated things. But yeah, as I go, please feel free to stop me if anything's unclear or whatever. Like, there's not many people on the call, so I'm happy to have it be more of a discussion rather than me just presenting. But yeah, so please feel free to just put something in the Zoom. But yeah. So as I'm sure most people are aware, Kubernetes by default doesn't come with the things configured in a secure way. There's all of the tools and wait a minute, let me just sort out the Zoom so I can actually see the screen. Yeah. So yeah, sorry. All of the tools are there and the options to configure things are natively built into Kubernetes, but it's just that you have to set them up by yourself. I guess this is probably a design decision to make it as easy as possible to get started without having to be bombarded with all of these options and things to configure. But in terms of how this works, I guess there's broken it up into four main areas for things where things can go wrong and where you need to take consideration. For the contents of this talk, I'm just going to focus on the first two, which is the containers, the things that you're deploying, and then the host, which will be the VMs that your underlying nodes are running on. Obviously, networking and stuff is a very comprehensive topic, and I think this would probably be better to be a whole webinar in itself where we can speak more in depth about the things that Kubernetes offers, but also things like Calico and Cilium and how these all like interlink together. And in terms of kind of the cluster level threats, these are more on us as the provider of the like Magnum clusters to ensure that these things are set up properly. But I guess responsibility does lie with you as a user to make sure that you're properly maintaining your credentials, you're not committing them to places where they're publicly accessible or onboarding services to ingresses that shouldn't otherwise be done so. But yeah, as I mentioned, it's quite a big like breadth of things that can be covered. So I think if you have an application that is maybe not as secure as you want it to be and you want to get it to a place where it is in good standing, I think you need to take it very slowly and go one at a time. I think trying to do all of these things at once becomes not only very overwhelming, but there's a very high risk that you break things. So it's better to kind of incremental changes rather than trying to rapidly fix things, because I think this allows you to progress in a lot more with a lot less pain, I guess, is essentially the ethos behind this. And this was something that I did quite extensively before I moved at CERN. I previously worked for a big consultancy company where we had to go through this kind of security hardening process. So like a lot of these steps I had to go through, and it was painful and it was difficult, but I think the gains are paid by the fact that the application is in a good standing now, and these things we can be confident in deploying regularly, etc. But one of the things that we learned is that this kind of analogy of Chesterton's fence, which is like to always question why things are done in a certain way. So obviously for the picture here, the fence is there because of the bull or the rhino in the background, but I think often it was very easy to dismiss that things were not secure or done in a proper way because people were being lazy or slightly negligent. But particularly at the organization where I worked, things were done in a certain way because of the constraints of how things worked in that organization. So rather than just assuming that things are done incorrectly, I think it's very important to question why people are often not following these best practices, because in some cases that is good reason for doing so. Like they need these permissions to do X, Y, and Z, and therefore this is why it has been done in a way that doesn't follow best practice. I think naturally what you'd want to do if you were in that sort of situation is making sure you're documenting why things have been done in a certain way, so that the next developer that joins the project doesn't have to then question, okay, why the hell has this been done for this reason? But yeah, this is just a small analogy for how it was when I was previously working at another company. So yeah, first half of the talk, I'm just going to give a brief overview of 2 or 3 very simple things that you can do in Kubernetes to get started. And then I will explain the integration of file code that we've recently done. So I guess in terms of where to get started, I think it's in the actual things that you're deploying. It's in how your containers are constructed and how they're built and the kind of things that are included with them. Obviously, there's a lot of guidance of this on the internet, but I think I just wanted to highlight maybe 2 basic examples. One using Go, where it's very easy to do things in a secure way due to the fact that you can statically compile all of your binaries together, and you basically have this one build artifact that you can then copy into a container, and this is what you then ship. Naturally, this doesn't always work because not everything's written in Go. There's lots of other languages that people use. So for kind of statically, for languages that require an interpreter, it's slightly more complicated, but I've given an example for Python, and I have a demo in later in the call which shows how I've used this to interact with some basic services at CERN. But I think the important things to highlight is making sure that, one, if possible, to remove a shell from your container, then this is brilliant, because what it means is that if that container were to be compromised, what an attacker can do with that is severely limited, because especially in the case for the Go image on the top right, if they gain access to this container, the only thing they can do is view the CA certificates and run the application binary. So there's not really any place to go from there. So I think it's about making sure that, assuming that if something can be compromised, how can I then limit someone moving from position A to position B? And so, yeah, one of the very basic examples is not including a shell. I guess the same thing applies with ensuring that you're not having like lots of debug tooling that is very useful when you're building applications, but in production isn't really required. So I think it's about making sure that you're disciplined and ensuring the images are built in a way that means that they only do what they're intended to do and can't be exploited. So we have some guidance on this, which I've linked at the bottom of the slides, and I'll attach the slides to Indico at the end of the call. But yeah, it's just at kubernetes.docs.cern, which goes over some of the very basic stuff, just summarizing how to build and appropriately distribute images. So moving on from this, like, what can I then do in Kubernetes? The way that this is chiefly controlled in terms of the permissions and how these images can be used is using what's called security context. So these allow you to specify what user it's running at, the SE Linux profile, the security comp profile, all these other things that by default, these are all kind of turned off, and like the application is running as root. You're not specifying a user, you have access to the file system. But yeah, this is what I said about it not being enabled by default, but then it's then very easy to get started. So I think the way that I would go about doing this is, if none of these options were set, would be to kind of start with the very basic things. So making sure the application isn't running as root, and making sure that somebody can't change it to be running as root. Like, this is an excellent first step in ensuring that your containers or tooling can't be exploited for a purpose other than what it's intended for. So I have like a few examples in the bullet points, which I won't read through, but obviously, as you go higher up the list, it can get more challenging to implement these. And based on the fact that there may be good reasons for needing these things turned on. There may be applications that need to modify file permissions for whatever reason. And so having them run with no privileges naturally doesn't work. So I think doing this in a nice incremental way will allow you to get up to this kind of stage of provenance. But how they actually work in security context is you specify them at a pod level, and by default, these will be inherited by every single container that's then defined in that pod. So the same thing works exactly in a deployment or a replica set in Kubernetes. If you were to then specify additional permissions at the container level, these will then overwrite or take precedence over the pod level ones. So yeah, I think another thing that I haven't included in this, I guess maybe because of space, is things like making sure that the config maps or volumes that you're mounting where possible have read-only access, or yeah, I think this is probably the main other one. I think there is another option to disable disable write access to the root file system, which is another good one to include. But I guess this comes with a cost, right? You strip out all of these things when you're then developing an application, it can then become somewhat challenging to actually debug things. For the Go example that I have here in the top right, if I just have this application binary and I want to figure out why a specific request isn't, a specific connection to a database isn't happening, it's very difficult for me to debug anything because I have no other means of doing anything in that container. So Kubernetes offers tooling to make this a lot easier. It's called ephemeral containers. And so on the right-hand side, I have a basic example of how this works. So this registry.k8.io pause image is essentially just a container that holds a namespace, network namespace. It doesn't do anything at all. And it's built as a distroless image, which means that it doesn't include a shell. So if I was to try and exec into that container, I get this error, which is basically saying I can't do that because this binary doesn't exist. What you can essentially do with these ephemeral containers is pick another image. So in this case, I have busybox.io. You can choose whatever you want, Debian, Ubuntu, whatever image that crucially has the tools that you need. I can then attach this to the container. So when I'm doing kubectl run ephemeral demo, what this is doing is creating a pod called ephemeral demo, which is what I'm referencing here. And then it also creates a container in that pod using this image called ephemeral demo, which is why the pod name and target name are the same, just because that can be a little bit confusing. But once I then have this command running, what I have access to is I have access to the file system, the container that I've choose to attach to. I have access to the network stack, and then I also have access to any of the running processes, so I can run things like ps-orgs and see what's actually happening inside of that container, which is very useful. So I was going to give a brief demo now, so I think I just need to change how I'm sharing the screen so that you'll be able to see my terminal. But essentially the demo is around how can I access a dbod instance at CERN, which is database on demand. For those people that aren't at CERN, this is an instance that allows you to provision MySQL, Postgres databases, and it's fully managed for you. But yeah, so the way that you then connect to this is to typical credentials. And so what I have set up, just can everyone see the screen? Is the size okay? Is it easy to read? If no response, I'll assume yes. Okay, perfect.
Yes, looks good.
Okay,
Yes.
cheers, guys. So yeah, I have a SQL database that I've set up in dbod. It has one table. It has this table called Falco, which has dummy data in. And then for the purposes of the demo, what I want to do is have a Python application that makes calls to this database with all of these kind of permissions and security context set, just to prove that I'm not blocking anything, and serve as an example or like a good starting point for how to go about doing this. In terms of how this looks, what I have is just an entry point that sets up my application. It loads the configuration from environment variables. So I'm using a library called Pydantic to do this. Not really relevant to Kubernetes, but it's a useful tool. What you can do is then specify each of the environment variables that I want to load, what type they are, and crucially, like whether they're secret or not. And this means that if I was to accidentally log out this information, then it basically gets redacted for you on behalf. But in terms of what the application is doing, it's just making a call to the database to list out what is shown in that Falco table. So what I should see when I run it is that every 10 seconds it logs out the detailed information that's in that. Obviously not very practically useful, but like all of the kind of plumbing is there to do things more complicated. And yeah, don't need to write a full web application to demo this. In terms of how this actually looks for then writing a deployment in Kubernetes, yeah, fairly similar from what the slides on were previously showing, but I specify a security context. So I specify a user of 65523, which seems arbitrary, but this is because I'm using a distroless image. And distroless images are provided by Google, and they're basically a way to make it easy to run interpreted languages like Python, but without having a shell image. So they're built using a tool called Bazel, and they will have everything that I need to package and run Python, but not a shell. And so if I just go back to the Docker file, that will probably show in a bit more detail of how this works. So in terms of how this is getting set up. I don't even see. Let me just make this screen a bit. Oh, there we go. I can see everything now. So I just basically install Python into a Debian image. Then I am building the dependencies in a virtual environment. And then in what actually gets distributed in my final image is I'm copying over the virtual environment, which has all of my dependencies, including Python. In this case, not really required, but I crucially just want to copy over only the things that I need and leave everything else in these kind of latter build stage containers that don't get shipped with my image when I'm pulling it in Kubernetes. And yeah, so essentially, just to reiterate, the distributed image is a way of making it easy to run applications without a shell, even though things like Python or I guess PHP would, where they have these dependencies and need kind of an interpreter to run. For languages that are statically compiled like Go or Rust, like using these things isn't really required because you can just copy them into a Scratch image, which is just a completely empty container. So if I go back to the deployment, in terms of how this works, yeah, I'm specifying the user and group that comes from the distrolist image. I'm saying I want it to run as non-root. And I specify this seccomp profile, which stands for secure computing profile. This is just a way of defining a set of permissions that can control what the application can or cannot do. So Kubernetes basically allows you to specify this runtime default, which from my experience has often almost been the one that I need to use to get things working. And then at a more granular level, what in the container, what I can do is specify the like specific Linux capabilities of what is allowed to do. So I basically drop all of them, but I guess in some cases you might need to add certain things. So you might need to add like net admin, for example, depending on what your application is doing. But in my case, I'm just making MySQL calls from a Python container to a MySQL server. So I don't need any of these fancy permissions. And then the final thing that I do is I just mount my credentials, which basically includes the password to MySQL, the username, the host, which is stored secretly, which is stored securely as a secret in Kubernetes. So if I switch to this terminal and do kubectl get I just have one credential that has 6 different values, obviously not going to show it for obvious reasons. And then if I were to then deploy this pod, the way that I can do this, as I'm sure most people are aware. Okay, so it's already deployed. So we do klog. And so what this is then doing is, as I said, it's being able to every 10 seconds just make a connection to MySQL and pull the data that's in this table, which is brilliant. So I guess not a particularly like interesting example, but it kind of shows that how you don't need a lot to get something set up in a way that's very secure like this I was able to do in like an hour or two. And so I have this code hosted on GitLab, so it's linked in the slide, so you'll be able to access it and have a look. But one thing which I can do now is demo how the ephemeral containers work, which is a way of attaching another container to this process. So because this Python image is running in a distroless container, as I've said many times, it doesn't have a shell. So if I was to do kubectl exec, then yes, I get this same error that I showed in the screenshot. What I want to do instead, if I just copy the command from here, kubectl debug, I specify the pod that I want to connect to. So just make sure this is the correct one. Then yeah, I'm using BusyBox, and then the name of the container is SQL client on the left. So yeah, that looks all good. And if I press go, yeah, so what this has done is now launched a shell into that container. If I was to do ps orcs, what I should see is that I have the processes from the container that I've attached to. So I have my Python command being run. What I then also have access to, if I can remember where exactly it sits, is I have access to the underlying file system. So this will just take me a while to get correct. There we go. So ls proc process number 1, the root system, and then non-root, which is the name of the user that the container is being run as. And then what I will be able to see in this is my Python code, etc. I guess some things to note with this is that this container will then inherit the permissions that is being deployed as part of my deployment. So if I was to try and do things that require root privileges, I won't be able to because the security context is limiting me from doing this. This is obviously by design. Like if I want to debug something, I want the same set of contexts and permissions being applied to my debug container as what's happening in the actual container. But what this means is that in some cases it may be difficult or not possible to like run package managers. So I guess the thing that I would recommend is choosing images that you attach to that have the tooling that you need. So if you need curl, if you need netcat for whatever reason, then you can either use the distributions that they provide or pick an Ubuntu distribution or pick some Linux distribution that has these things pre-installed. So we have one as managed by the Kubernetes service that has like lots of the typical Kubernetes dependencies that we manage. So when we want to debug stuff in our own service, then we can just use this image that's pre-built for us. But often in most cases, you'll be able to use like a third-party distribution and be able to debug and do all the things that you'd want to do with these containers. So that was all I had in terms of the kind of very basic runtime things that you can do in Kubernetes. Obviously, this is somewhat of a rabbit hole and you can go down to a lot more depth, but I think for the purposes of this, I just wanted to give a very basic demo of the things that you can do and how these can then be used immediately. And yeah, I think you kind of tick these things off and then you can gradually progress to doing more complex pieces of work. So what I will do now is go on to talking about Falco, which if I just switch back to the slides. Okay, perfect. So yeah, as mentioned, this has been added into the last release, CERN Magnum, which is the Kubernetes distribution that the team manages. And this tool essentially aims to give you insight in when things are happening in your cluster that you wouldn't otherwise expect them to be. So this could be maybe hackers or maybe somebody that's messing with production, etc., when they shouldn't be. But this is a tool that you install in your cluster and allows you to monitor the events that are going on with it. This is part of the Cloud Native Foundation, and it's a tool that's not only designed for Kubernetes, but can also be run on VMs as well, using exactly the same set of logic and writing rules and all these other things. So yeah, this isn't just for Kubernetes. I think it was initially designed with the goal of monitoring VMs, but then it's been adapted and you can deploy it via Helm into Kubernetes. In terms of how this works, essentially it is monitoring for kernel events, and you then will define a set of rules which basically outlines the behaviors that you want to trigger alerts on. And these alerts are then get forwarded to kind of third-party providers for your processing. So I think I have this gives a better example. So you have a kernel module which will monitor things that are going on in the kernel, specifically on things like the node, but then you can also you can also monitor the Kube API server and look at things like the audit logs in Kubernetes. So for those people that aren't aware what these are essentially logs that track everything that's happening in a Kubernetes cluster. So whenever an object is modified, deleted, edited, etc., what this will do is log out a line for you. And so what Falco can do is it can listen to the audit logs via a webhook, and then you can then trigger events off the basis of that. So I guess like a good example for something that you might want to trigger an event for is if somebody modifies something in the kube system namespace. This is a namespace that's typically shouldn't be touched by like users of the cluster. It's typically people that are provisioning the cluster that control the resources that are in kube system. So in our case at CERN, when you install a cluster using OpenStack, all of the resources that are used to access CERN services get installed into kube system. So in most cases, you shouldn't really need to modify or adjust any of these. They should be working for you. And the same thing works in the cloud right? So if you're deploying a cluster into Google in the GKE, the tooling and integration for interacting with the storage systems in Google, it gets deployed into Kube system. So if somebody's messing with that, they probably shouldn't be, which is a good example of something that you may want to trigger an alert for. And so the way that you would do that is Falco is monitoring your audit logs, and then what you would then do is craft a rule that is designed to kind of pick out this event and then forward this to one of the other alerting sources. So by default, how we have Falco set up at CERN is that it just logs the events to STD out. So if you were to do kubectl logs, then what you'll see is these events as and when they're happening. This is obviously not very useful. I mean, it's great to have and is a good starting point, but ideally what you'd want to do is configure a third-party source so that your alerts are forwarded to something like Alert Manager, PagerDuty, Grafana, or even like you can just have messages sent directly to Mattermost, for example. So we have documentation and guidelines for how to get all this set up, and at the end of the presentation, I'll give a demo of roughly how this works, but we set everything up for SED out just to like the minimal entry point, and then if you have your monitoring enabled in your cluster, then it's then very easy to configure this forwarding of alerts. And so this is done through another tool called Falco Sidekick. So both Falco and Falco Sidekick are deployed as part of distributions at CERN. So this is included in the last release. So this is Kubernetes versions with an API server of 1.31 or greater. And yeah, as mentioned, by default, these alerts are only logged to STD out, but it's then very easy for you to configure and forward them to a source of your choice. So we have in our documentation explanations for how to set up alerting to these three sources, which I guess we as a team have assumed are probably the three most common places that you want to send alerts. But Falco Sidekick offers lots of other support and resources for this. So there is many integrations that you can use. And on the right-hand side, I just have a very brief snippet of basically how to configure all three of them at once. You probably wouldn't really want to do this. You'd maybe only want one or the other, right? You'd send your alerts to Alert Manager and then have some other webhook from Mattermost that is speaking to Alert Manager. There's not really a reason to have all three of them, but for the purposes of like keeping everything in the demo and slides, I've just pasted it there for you. So the way this works in terms of setting up for Alert Manager, all that you need to do is basically point Falco Sidekick to Alert Manager. So in this case, in CERN Magnum, this gets installed to this URL here. I don't think you can see the mouse, but yeah, CERN Magnum-Kube Prometheus, blah, 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 blah. And then you just specify the priority of alerts that you want to send things through. So Falco has like an extensive level of filtering, much in the same way that you would for logs. So you can choose to filter on only the highest priority, or you can choose to have these warning logs. So by default, we have everything set up so that you get pretty much everything. And then the idea is that you'd maybe want to gradually refine this and turn off things that are useful or slightly spammy. And yeah, so once you have this kind of YAML file, you just run the standard OpenStack create cluster and then pass this in as a base encoded blob. And what this will do is set up your cluster for you. If you're not using CERN Magnum or you set outside of CERN, then Falco's distributed as a Helm chart. So the kind of same sort of logic applies. You just do Helm install and pass in your values. Yeah, so very easy to get set up for you. And yeah, I guess a key thing to highlight with Falco is that it doesn't aim to stop you, or it doesn't aim to prevent anybody from doing anything malicious. It's only focused on kind of understanding what's going on in the cluster. So the idea behind this is that you'd have Falco running and you get alerts for when things are happening. And I guess what the kind of way they propose this in your docs is that in their docs is that you leave Falco running, you get an idea of the weird things that are happening, or sorry, no. You leave Falco running, you get an idea of the natural things that people are doing in a cluster that would otherwise trigger an alert. And then you then modify the alerts so that you're only getting alerts for when people other than you are messing with your cluster. So this would be, you know, an attacker, etc. Writing the alerts, I would say, is quite difficult. You need like very specific domain knowledge of what's going on in the Linux environment to write these alerts in a way that's useful. But fortunately, Falco provides like most of the default ones that you would want out of the box. So in CERN Magnum, we have the Falco's default rules allowed, and then we also set up monitoring that pulls the events from the audit logs in Kubernetes. So I think most of these, having these two will cover like the 80 to 90% of the things that you'd want to trigger alerts for. And then I guess if there is a more specific thing, what you would then do is you can then write your own alerts. And these can be managed as OCI artifacts. So you can have your alerts packaged and stored in a registry, and then Falco will essentially, when it starts up, pull the alerts. Or what you can do is you can have the alerts written as part of your values.yaml file that you use to configure Falco or CERN Magnum. These are slightly more advanced, but I guess, yeah, I want to highlight that it is possible to tweak everything that's going on. You don't need to rely on the default setup of Falco. Yeah, so I've probably covered this already, but yeah, here's an example of, say there are specific things that me as a cluster administrator or as a development user in a cluster, I want to be able to manually change secrets, which, yeah, I guess maybe let's not debate whether this is good practice or not, but like in some cases you would need to modify these things. And so what I would want to do is not trigger an alert for when I'm doing something, right? You want the alerts to be only for things that you need to actively respond to, otherwise you get alerting fatigue and everybody ignores them. But Falco is written in quite a clever way, which allows you to kind of layer alerts on top of each other. So what I've done here is I list out the application users that are allowed to modify things. I then define a condition which determines whether the person that is modifying the secret is in this allowed users. And then what I can do is then append on top of a specific rule. So this rule here, noisy alert, i.e. K secret get successful. This will be something that has already been predefined in another set of rules. So this will be like what comes as part of the default packaged rules for Falco. And basically what I'm then able to do is append on top of it to adjust the behavior. So it means that I don't need to rewrite everything to adjust how things are happening. So what we have done in CERN Magnum is for some of the default things that will trigger alerts, things like Calico, which may have good reason for modifying things, or which does have good reason for modifying things. We have then modified these alerts without needing to rewrite everything, basically. So in the slides, I have a link to the kind of Falco rules that they provide. They're very extensive, but yeah, they may be useful to have a read and understand like how these alerts are actually written, so that if you then want to write your own specific alerts, you can then go about doing it. Okay, perfect. So I will switch back to the terminal now and just give a brief demo of how the alerting integration works for Prometheus and Alert Manager. So okay, perfect. So in this cluster, this has just been deployed using CERN Magnum. What I have is, let's just do this instead. So I have the demo application, which I used earlier, and then I have Falco and Falco Sidekick deployed. And then the standard kind of set of things that get deployed when you are provisioning a cluster using CERN Magnum. Importantly for this demo, if I want to use Alert Manager, then I need Alert Manager installed. So I've just enabled monitoring in the cluster. In terms of how I then go and set up Falco, is very much using this kind of YAML snippet that I've shown in the previous slides. I can show the full configuration for if you're not, no, this is the wrong set of folders. So if for whatever reason you're not using CERN Magnum or you're set outside of CERN, then if you wanted to set up all of these things in the exact same way, this is the configuration that kind of does everything. So much of this, if you are using CERN Magnum, you obviously don't need to provide. You just use the snippet that I showed in the slides, but this would be absolutely everything to get it working from scratch. So you specify the rules that you want enabled, for example, where they're installed from, and then you configure Falco Sidekick, which is the alert forwarding. So in this case, what I have set up is I have a service monitor, which will allow me to pull Prometheus metrics, and then I just point Falco Sidekick to Alert Manager. And what this will do is directly send alerts to Alert Manager. Falco is doing this directly. It's not creating Prometheus rules that Alert Manager would then read. It's directly forwarding the alerts to it. So obviously you could do this in a different way. You could have Falco Sidekick writing metrics to Prometheus and then writing your own rules, which would then trigger Alert Manager off the back of that. But they offer this integration, so I have it set up for this because it's a little bit easier to get started and requires a little bit less knowledge of how everything's working. And so what I can then do, if I just close some of these to make it a bit easier to read, is Falco basically provides this tool or provides a container, which I will just show you. So this is essentially designed to trigger lots of bad things in your, or trigger things that would otherwise create alerts. And so what you can do is use this to monitor that Falco's initially set up correctly and that your alerts are working properly. So what I can then do is if I deploy this into my cluster, this out of the way. That's okay. What I now have is this pod. So if we look at the logs for it, it's just logging out all of the things that it's done, which would otherwise generate an alert. And if I was to then look at this from Falco's perspective, come on, let's pick this one. So, right, lots of things were dumped out then, but I will just maybe highlight one of these. What this is then doing, because by default, what we have in CERN Magnum is the alerts are logged to SED out, is you can see all of these alerts as they're being triggered. Obviously, there's a lot going on. This is designed to create lots of noise. But as part of having this set up, what I will then be able to do is look at Prometheus or look at, so start with this one. So if I forward to Prometheus, and then I'll need to change the screen again. Let's just do this instead. Work. Okay, yeah. So what then happens is Falco is writing under the metric Falco events, and then I have a list of all of the different things that are being triggered. So maybe it's a bit small, just zoom in on a basic one, but drop and execute new binary into a container. This is naturally something that would not really be done other than if you were trying to exploit a piece of software. So yeah, from here, you could then write Prometheus rules that would then trigger alerts. But as I mentioned in this demo, what I have done is set up it to forward the alerts to Alert Manager directly. So if I just switch to that one, we can see what that looks like. So it's Alert Manager. Yeah, okay, yeah. So yeah, it's a standard watchdog alert, and then we have an alert, lots of alerts for various things that are going on. So this is exactly the same as what's being shown in the logs and what's being shown in Prometheus, but it's just another way of showing how you can forward these alerts using Falco Sidekick. And yeah, that was kind of everything I had in terms of demo for Falco Sidekick. If we just switch back to the slides. And yeah, the wrap up now, but this is the kind of final steps, which is, I guess, where do we want to go with this at CERN? And, or where could you go with this once you have Falco set up? So we're currently working to integrate the Falco setup with the central monitor instance. And so this would allow everything to be configured in a very easy way. You wouldn't need to go through this process of setting up the integrations with Prometheus or Alert Manager because they just come packaged as part of central monitor. Or not, sorry. Or they just come in a way that is then very easy for them to be integrated with central monitor. There's no, they could just be by default working essentially when you install a cluster in CERN Magnum. And then I guess, yeah, the other thing is expanding on the rules that we have, because currently we have just the default Falco rules are being used. And I guess there's a lot more specific things that we might want to do tailored to how things work in CERN Magnum. So we're going to work on expanding out these rules. And then I guess from a next step is Falco is able to alert when things are happening, but how do you actually stop and intervene and prevent people from doing bad things? And Kubernetes has a mechanism for this, and it's called admission controllers. So what this will do is whenever a request is sent to the API server, something will evaluate whether it's valid or not, and it then can choose to reject that, or it can choose to mutate the request. So an example of how this could work is if I attempt to deploy something from a given registry, I could choose to just completely block it. So if, say, we wanted to block, I don't know, GitHub container registry for whatever reason, you could then using one of these admission controllers, stop it from happening. Or what I could do is I could say, okay, don't use GitHub Container Registry. Instead, I want you to use GitLab. So if we had like a mirror setup, I guess a good example for this would be the registry is if people are trying to pull things from docker.io, what we would then do instead is mutate this request to use the proxy cache. So instead of pulling it from docker.io, we'd pull it from registry.cern.ch/docker.io. So we're then making use of the cache in Harbor and not coming into these rate limits. But yeah, there's two tools for doing this that we're currently exploring. They both work in slightly different ways. I've just dropped them in here for reference, but yeah, I'm not really going to talk about them because they're both quite complex. But there's Open Policy Gatekeeper and there's Converno, which both do very similar things and work in very similar ways. But there's pluses and minuses to using both of them. So yeah, this was everything I had. I guess I'll pause for questions or happy to take any comments.
Jack, I don't see any questions in the chat so far.
Okay. Okay, I mean, if there's no questions, I'm happy to take stuff offline, or if you just want to give me a message, I'll post the slides onto Mattermost. Not Mattermost, post the slides onto Indico after the meeting.
I think that's it. We can
Okay.
stop recording.
Yeah, I will figure out how to do that. Or is that done for me?